The International Laboratory for the Identification of New Drugs, or the Iliad Project, was an initiative started by Josiah Zahner and Mark Opel. Their initial goal when starting the project in 2013 was simple. Instead of relying on research institutions and pharmaceutical companies to come up with new antibiotics, ask citizen scientists to do it instead by having them test specimens like plants and insects for antibiotic properties. The funding that they sought through a Kickstarter service didn't end up hitting the goal that they set. However, even 3 years later, they still allowed us to purchase some of the equipment that they were selling in the original project. Enter the Stratford Iliad Project.
We are the Iliad. Over the past year, we have immersed ourselves in this project in an attempt to discover natural antibiotics in common plants in the Houston area.
We collected plant samples and compared their antibiotic properties to that of kanamycin, our control antibiotic. We tested this by using non-pathogenic E. coli with a low rate of mutation.
To prepare the plant samples, we used a mortar and pestle to concentrate the plant, and we stored that concentrate in microcentrifuges for future use. We ran our tests in petri dishes filled with LB agar media, a nutrient broth that stimulated bacteria growth. When we first set our tests, they looked like this. After 48 hours, they looked a little bit more like this.
To measure our results, we used what we call a K ratio, a direct comparison of the radius of the plant sample zone of inhibition to the radius of the kanamycin zone of inhibition. From there, we were able to find an average value of each plant, and then find the average percentage of effectiveness for each plant compared to the kanamycin.
Of the baseline plants we tested, the ones that exhibited antibacterial properties were garlic, lantana, rosemary, and onion.
The plants whose data yielded the most statistically significant results were garlic and lantana. The p-value for these plants was extremely small, almost zero. This means that if these plants did not have antibiotic properties and exhibited the results that we saw in the lab, then there must be some other factor involved.
We found a statistically significant difference between garlic and lantana. Garlic worked at about 67% effectiveness, whereas the mean effectiveness of lantana was about 43%.
We also found that garlic prepared without heat worked more efficiently than with heat, and newer prepared garlic worked better than older garlic. However, the difference between heated and non-heated lantana was not statistically significant, meaning that the difference in results is most likely due to random variability.
So after we developed the baseline, we decided to go on an adventure and go and find some plants to test.
Percent of the plants we collected yielded samples that exhibited antibiotic properties. However, only 50% of those plants we collected yielded results that were statistically significant, which means that the probability that either plants 1 or 7, exhibited the observed results in their K ratios, was higher than that level of significance of 5%, meaning that the results we observed could simply be due to variability. That said, 40% of the plants collected passed with less than a level of significance of 1%.
After identifying each plant, we found a common theme among those that exhibited antibiotic properties. Those plants that did have those properties were classified as toxic. A couple of those that we tested were lantana and butterweed, and the toxins within them are classified as liver toxins. And so those primarily affect cattle and horses, and they lead to problems with liver deterioration, jaundice, and photosensitization, which causes sensitivity to sunlight. In humans, it also causes symptoms like diarrhea, stomach aches, and vomiting. So those are all related to dietary functions. And so E. coli, which is the bacteria that we use to test all of these plants on, is primarily found in the human digestive tract in more benign strains. And so those two things could be directly linked to one another in terms of how they could be used as human antibiotics, as the effects on humans could be limited to a certain extent.
This graph serves as a summary of our results from this project. Garlic, lantana, rosemary, butterweed, stickyweed, Carolina germanium, and fungi all exhibited antibiotic properties and were relatively effective against our control, kanamycin. When concentrated, these plants were able to serve as natural antibiotics that inhibited the growth of E. coli.
So we were not able to buy and experiment with like big money research tools such as CRISPR, the new things that are coming out, but we were able to learn the basics of testing and lab work and how to keep variables constant, and we learned the basics of the problem of the superbacteria, which is relevant to our fields in the future.
And through this whole process and this whole project, we were able to gain so much knowledge and understanding about the fields that we want to go into and what we want to study when we go to college. And we hope to use this research to expand on what we already know once we get into higher education and our future careers.